Dear students, I hope you very well understood crystal lattice and unit cell. So crystal lattice refers to the whole crystal, arrangement of all particles in the whole crystal, and unit cell refers to the smallest part of the unit crystal lattice. So unit cells, how many unit cells are present? Large number of unit cells are present in a particular lattice. Large number, millions of atoms are present in a crystal lattice, and thousands of unit cells make one crystal lattice. So each unit cell is connected with another unit cell. They are in direct contact. So in three dimension. Three dimension means if you consider the right side, left side, this is x-axis, and top, bottom, this is y-axis, front and back, this is z-axis. So in all three dimensions, the same unit cell is repeating. So that constitute the crystal lattice. What about coordination number? So see, let it be a bench. This is like a unit cell. So let it be one student. So it is like an atom. The number of nearest neighbor of an atom in a unit cell is called the coordination number. Number of nearest neighbor. See, if you consider this student, he is surrounded by 1, 2, 3, 4. Direct contact, nearest neighbor. So the 4 students are surrounding this student. So similarly, in a unit cell, a particular atom has particular number of nearest neighbor around it in 3 dimension. Again, in 3 dimension. This is only 2 dimension. In 3 dimension, that number is called coordination number. I hope you remember the structure of sodium chloride. In sodium chloride crystal, if the sodium plus ion is present, 6 chloride ions are surrounding this. How? See, this is one Na plus ion. This is Na plus ion means 1 Cl minus front, 1 Cl minus back. So this is one axis, one dimension. Third here and fourth here, top and bottom. This is another axis. Fifth in the right side, sixth in the left side. So 6 chloride ions are surrounding, 6 chloride ions. So what is the coordination number of Na plus means? It is simply 6. So this is coordination number. So you should have better knowledge about the crystal lattice, unit cell and the coordination number to have better understanding of an internal structure of crystals. So next we will move on to the unit cell. Let us mainly concentrate on the unit cell. If you are very clear about unit cell, we will be familiar with the internal structure of crystal lattice everything. So going to unit cell, we can give an imaginary shape or imaginary geometry to the unit cell. Imaginary geometry means we have to imagine. See, let me illustrate. These are all the atoms or molecules arranged. So this is in 2 dimension. These are all the atoms or molecules in a crystal. So these are all different atoms. So to decide about the geometry of a unit cell, let me consider any one atom. So let it be the atom at the origin. I have to assume the 3 axes. Let it be x-axis. So this is y-axis. This is z-axis. So these are called crystallographic axis. Crystallographic axis. I selected one atom in the crystal lattice, assuming x, y, z axis, 3 axis, 3 dimension. I have to find out 2 parameters. One is the distance between the adjacent atom. Distance between an atom at the center and the adjacent atom in x-axis, y-axis as well as z-axis. See, this is the adjacent atom in x-axis. this distance. This is the next atom, adjacent atom in the y-axis, this distance. Similarly, this distance. This distance can be in the x-axis, let it be A, in y-axis, let it be B, in z-axis, let it be C. So this distance is called edge length. So very important term you are going to come across in this lesson, edge length. Sometimes it is called a lattice constant. So this is edge length. Next parameter, very important parameter, is the angle. So the angle between x and y, this angle between y and z, angle between z and x. So let it be alpha, let it be beta, let it be gamma. So alpha, beta, gamma. These are all called the interfacial angle. Interfacial angle. So these two parameters are important in deciding, in knowing the geometry of an unit cell. If we could able to measure these distances and interfacial angle, we can give an imaginary geometry to the unit cell. By knowing the imaginary geometry, we can move into the crystal lattice and the actual arrangement, orientation of the atoms, actual in 3 dimension, we can decide. So these two parameters are important. By knowing this, we can design the geometry. So,